the intercepts, actually let's talk about asymptote first, but I want you to think about domain, range, in behavior, and intervals of increase or decrease. And I want, it's M3-110. Nope, go back. Oh yeah, that's it. Okay, first things first, we need to define what an asymptote is. This is one of the words on your graphic organizer, probably like the fourth word on there or so. And so here is the definition of an asymptote. An asymptote is a line or curve that another curve approaches towards infinity. Once again, this is a simple definition. There is more that you would want to add to this on the graphic organizer and other things like that. But at its simplest definition, asymptote is a line or a curve that another curve approaches towards infinity. So, what representation would you need to look at to identify an asymptote?
A graph.
A graph. That's important to notice. We're talking about lines and curves up here, right?
Mm-hmm.
So to be able to see those asymptotes, you got to graph it. To see those asymptotes, you got to graph it. Maybe. Come on, I cannot give you any more clear information that you need to know other than this on the board. You got to make a decision, pick up your head, pick up a pencil, and write something down. I can't do it for you. So Robert, do you see anything that we might describe as an asymptote? Looking at those graphs?
Yeah.
Where? So like the curve itself is the asymptote? Say again, Caleb?
Domain range.
Okay, but domain and range are all of my x values and all my y values. What is the definition of an asymptote?
That
A line or a
approaches
curve.
towards infinity.
That another curve approaches towards infinity.
You got something to do with that one, because that's only going towards positive, isn't it?
Well, what's going towards positive infinity?
The line, the curve.
Okay, but y'all are forgetting, there's always two variables you have to think about.
The X is going towards infinity.
Okay?
Oh.
So as x goes towards infinity, y goes towards what?
Negative.
For the
We're going
growth?
up, so then it's positive. So it's infinity. Then it's positive
It's
infinity.
going up, so it's positive infinity. Is that a line or a curve that's approaching, or is it just approaching infinity?
It's approaching infinity.
It's just approaching infinity. So it's not that.
So,
What about on the other side? As x goes towards negative infinity,
Why just go straight though?
it doesn't just go straight,
Well,
but
it's
it
gonna
does. But when you say straight, what are you thinking about? A what?
A line?
A line. Wait, what is an asymptote?
A line or a curve
That another curve
approaches.
approaches.
towards infinity.
Is this approaching a line?
Yes.
Which line? The x
Axis?
axis, right?
Yeah.
But there is an actual equation for that asymptote. Huh? You what? Do y'all not know the equation for the axis of symmetry? Or the x-axis, I mean?
No.
Okay. Let me ask you this. And if you don't know this, you might need to take some notes, maybe putting this near the asymptote thing. But does anyone know what this point is?
1,
No.
2,
No.
3.
No.
Wait, what's the question?
None of you have said a point yet.
Oh,
so
you're like-
1,
No.
0, 1.
No.
1,0.
Thank you.
Oh wait, it's X and Y.
It's x and then it's y, right?
Yeah.
1 comma 0. What is this point right here?
-2, 0.
We'll get on those points so far.
Yeah.
What about this point?
-4. I mean 4, 0.
Anybody want to push back on that, or do we all agree?
Agree.
Agree? Okay, what about this point?
5, -5.
Okay. I'm going to pause for a second. I want you to reflect and look at this. Mia, what does every point on that x-axis have in common?
0.
There's more that you need to say with that.
The Y is 0.
Ah, the y is what? Hey, does anyone know a mathematical way to say y is 0?
X-intercept.
I don't know why I was supposed to
The
say Y
x-intercept
is
always
0.
has a y of 0,
Yeah.
but listen to my statement again. What is the mathematical way
Y
to...
approaches 0.
But see, that is y approaches 0. We're not saying y approaches. We're saying y, what? Y is equal to 0.
I thought your x-axis was no.
Yes.
Yeah, but
The x-axis goes across. But look at every point on the x-axis. What is the y value? 0. So even though it is called the x-axis, on the x-axis, y is always equal to 0. That is important to notice. Even though it's called the x-axis, y is equal to 0 for every point on the x-axis. See a few of us being diligent writing that down. I appreciate it. So I'll wait a second.
Do it.
Now, when I'm being emphatic, that is a time to write something down. And I appreciate those of y'all who spread over emphatic.
Yeah.
EMPHATIC.
I would
Oh, I
say
thought it was
I would say I.
Emphatic. That's, I don't think that's a word.
It should be. It sounds better than what you said.
If you don't know the actual word, but emphatic sounds good when you know what that word is. So, I will bring this up because this will matter in the future. So, equation for, alright. So, what would be the equation for the y-axis?
X equals 0. I guess.
That would be logical, wouldn't it?
Yeah.
So let's check it. Again, this will matter for future lessons. Okay, what is this point up here near the top?
0, 4.
0, comma 4. Robert, what is this point right here?
0, 1.
Okay. Kanye, what is this point? 0, comma negative 3. Devin, what about this point?
0, -5.
Okay. So Caleb, what does every point on that y-axis have in common?
0.
X is equal to 0.
The x is equal to 0. And you're fine, but I want y'all to notice. That means that the equation for the y-axis, and this is something a lot of students get messed up, the equation for the y-axis is x equals 0 because every point has an x value of 0. Alright, you gotta know that information so that we can now talk about asymptotes.
You said every. What equals 0?
Every x value is 0 on the y-axis. Right? And that's why I drew out this example. Drawing out a quick little graph to show that is not a bad idea. That's how we root our understanding. It's not magically made up. It's, hey, on that y-axis, every point has an x value of 0. Oh, x is equal to 0.
I want to know what is made of
Well, in my understanding, the way I think about it is, there was God who created math, and then things that are created tend to be discovered.
Yeah, well, I'm not gonna say what I was
You can say it.
So where you think math came from?
Huh?
Where you think math came from?
God created it?
I feel like
God
folks just be
created math.
counting it.
God just said,
It
add me
started
Yeah,
equal.
from-
like, who was
Right.
added over
Right.
here, so what is there?
Yeah.
But what are, do you know what the building blocks of the universe are built out off of?
Lost.
Math.
Yeah, numbers.
Numbers. Like legitimately, the way you look at the world, there are things called, well, there's ratios throughout the world that are defining the way that the universe is set up and organized. And if you look at things like physics, right? Physics is literally looking at how physical objects operate in the real world. Math was necessary to understand and explain those things. That's why calculus exists. Isaac Newton developed, or was one of the developers of calculus to help him understand physics. Everything can be tied back to mathematics in the real world.
They shouldn't have
You
discovered
think like, you think somebody like can create something new in math like now?
So, I don't know. Most of mathematics that I know of was all discovered in nature. I don't know if you can create math or if it's still just rules that we're discovering. I know most of the math that like y'all study is discovered, not created.
Mr. Kenny,
Ma'am,
why do they say Columbus discovered America?
because people are dumb.
Okay, I'm glad you agree with me.
I mean,
Cause it don't make sense. Like, there are people here,
He
When
discovered
he
it for
came
the new
here.
world.
well,
but
that's
they were
because
already inhabited though.
that's because we always look at everything from a European lens.
Yeah.
Because white people founded America, and so that's all that they look at. And that's how history has been written for years upon years upon years.
Well, I think it's time we start changing it, telling the truth.
What's the truth?
That Columbus done discovered something that people already had inhabited. There's a lot of other stuff in history that they don't tell the truth about.
I mean, he wasn't even really the first European. He was the first European to come to America and go back. But I mean, even he didn't think it was America. He thought it was India because he was stupid.
Oh yeah.
And y'all, no,
Amerigo Vespucci was the first one who realized that it was America,
America was Gucci.
which is why it's called America.
Who is America? Like who is that?
Amerigo Vespucci?
That's who
Ain't
they
never
named
heard
That's what America was actually named after because he was the first one who realized it was a new world
Oh, I ain't never heard.
to the
of
Europeans. That's
Crazy.
You didn't take
disturbing.
Morrison last year?
I do, but.
I ain't even watched.
I don't know.
Alright, hey, we got math to do. Okay. All that to say, an asymptote is a line or a curve that another curve approaches towards infinity. So what would we say the asymptotes are for the exponential growth and the exponential decay?
X for, wait, yeah.
Well, what did we already say that the functions are approaching? The what?
The line,
Which
the
line?
x-axis.
The x-axis. So what is an equation for the x-axis?
X equals y equals 0.
Yeah.
These functions are approaching the x-axis, so the asymptote is y equals 0.
Yep.
Now, within your small groups, we need to be working on filling out the rest of this table.
What time we get out of here?
2:05 is the last I heard.